All right, so now let's talk about piecewise functions as we continue in this section of college algebra. And I'm going to do a really rough, okay, it's not going to be actually perfectly correct, okay, but I'm just going to do a rough draft of what a piecewise function is just to make a point. So let's just do an axis, and let's put some numbers on it. And then I'm going to do like a V shape from here to here. And then I'm going to do something like this. And then like that. Okay, so what I have is like parts of a function. Like this V-shaped part is like my absolute value x between the -4 and the -3. Between the -3 and the -1, it looks kind of like x cubed. And between the -1 and the +1, it looks like an x squared function. Okay, so those are some of our basic functions, our parent functions. So what happens now is they write this as a piecewise function. They say, okay, this is in 3 parts. Part of it's the absolute value looking function, part of it is the x cubed looking function, and part of it is the x squared looking function. And then they put this large brace here. Well, they say, well, it looks like the absolute value of x when it's between -4 and 3. So they come over here and they put between -4 and 3. And it looks like x cubed between -3 and -1. So x is between -3 and -1. And then it looks like x squared between -1 and 1. So x is between -1 and 1. And they'll put a comma between these. Okay, so they'll do something like that. Okay, and that's not, that's not exactly correct, but close enough to kind of get an idea of what's going on here. Okay, so that's what a piecewise function sort of looks like. So now, here's more of the real deal. Okay, let me give you all a minute to write that down. I may have gone too quickly there. So here is more of a legit kind of example. So this time they give me the piecewise function and they say you graph it. Okay, so really it's defined in 2 parts. Some of it is x squared plus 1, but some of it is x minus 1. Well, x squared plus 1 is our parabola, and x minus 1 is just a straight line, a linear graph. So let's take a look. Now, these are called your parameters, these numbers and these inequalities. So let's do a table, but make sure you get that parameter in your table. Okay, so I'm going to put it in the middle here. And then I'm going to make up some more x values. Suppose I make up -2, -1, 0, and 1, but make sure 0 is in there. Okay, so if I put -2 in this equation, -2 squared is 4, and 4 plus 1 is 5. If I put -1 in this equation, -1 squared is 1, and 1 plus 1 is 2. If I put 0 in this equation, I get 1. If I put 1 in this equation, I get 2. So this would be what the graph look like. Okay, -2, 5, -2, 5, -1, 2, 0, 1, and 1, 2. So this is what my graph looks like. Now, I can't have all the graph though, because this states this x less than 0 means to the left of an x value of 0, right? To the left of an x value of 0. So here is my x value of 0 at the origin, so I can only have the left side of the graph, not the right. So I need to erase it, and I think it's going to erase the whole thing. Oh, it didn't. It did a pretty good job. So I only get to have the left side of the graph. Now, one more thing I have to be careful of is right here at the point 0, 1, I need this to be an open circle. Why do I need that to be an open circle? It's a less than, not a less than or equal to. Okay, so now let's do the other one, x minus 1. Now 0 is one of my parameters, so I need to get 0 in here. And maybe I'll have negative 2, negative 1, 1, 2, but get 0 on that table. Okay, when x is negative 2 minus 1 is negative 3. When x is negative 1 minus 1 is negative 2. X is 0, negative 1. X is 1, 0, x is 2, 1. Now this is going to be a straight line because this x is not squared or cubed or square root or absolute value, it's just plain x. So negative 2, negative 3, negative 1, negative 2, 0, negative 1, 1, 0, and 2, 1. Yes, that is most definitely a straight line linear graph. Now, I cannot have the whole graph because this is not going to pass the vertical line test. It will not be a function. So part of it has to go. Well, this parameter says x greater than or equal to 0, and right here at 0, negative 1 is where it equals 0. So everything to the right I get to keep, but the stuff to the left has got to go. So I start here and go up, but I cannot have anything on the left side. And now it will pass the vertical line test. Now it is a function, it is a piecewise function, and it is graphed in pieces. Now, I filled the circle on the bottom because that was where it included the 0 in the inequality, greater than or equal to. All right, let's go down to the next one. It does not like to go. There we go. Okay. All right, so here is another piecewise function. It is defined in 3 pieces, 3 parts. So one part is y equaling negative 1. The other part is y equaling x minus 1. And another is y equaling a negative 2x plus 6. There's your 3 parts. I don't know how I'm ever going to get all this in here. Okay, so y equaling negative 1 is my horizontal line at negative 1, right here. This is my y equaling negative 1. But I can only have it when x is less than 0. X is 0 at the origin. Here is where x is 0 and y is negative 1. I can only be to the left of that point. So this graph, can't have all of it, this graph is going to be only at, it's a hole, right? It's an open circle at the point, and to the left, like that. That's all I get to have. Okay, y equals x minus 1, you have 0 and 2 in its parameters, so when you graph this, be sure you get the 0 and the 2 in the table. If x is negative 1, negative 1 minus 1 is negative 2. If x is 0, 0 minus 1 is negative 1. If x is 1, 1 minus 1 is 0. If x is 2, 2 minus 1 is 1. Okay, this is supposed to be a straight line. So negative 1, negative 2, 0, negative 1, 1, 0, and 2, 1. Yes, it is a straight line. But I can only have it between the x value of 0 and the x value of 2. So here at 0, negative 1, that's my x value of 0, filling in the open circle. And at 2, 1 over here, it's also filled in, and the rest of it has to go. So I don't know if it's going to let me do this. Let's see how. Nope. Okay. So I'm between here and here, and it's filled on both ends. Okay, 2x, negative 2x plus 6. Its parameter is just a 2, so make certain you get a 2 in the table. Maybe we'll have a 0, a 2, and a 4. And it's going to be a straight line. Okay, when x is 0, it's 0 plus 6, which is 6. When x is 2, it's negative 4 plus 6, which is 2. And when x is 4, it's, 2, negative 4, 2. When x is 4, it's negative 8 plus 6, which is negative 2. 0, 6, actually it's going to be up here a little off the graph. 2, 2, and 4, negative 2. Here's this graph, a straight line, like this. But I cannot have the whole line. It has to be only to the right of the x value of 2. So this is the point where x is 2, that is the point 2, 2, and to the right of it, and the rest of it has to go. So, and is this a filled circle or an open circle? Open. Open circle, coming down. It should be straight. Mine is not very straight with this pen. It's supposed to be a straight line, like that. And there's your piecewise function. Now they have an interesting question here. This function was named z instead of f. So z at negative 2. Go away. Z at negative 2, right? Well, negative 2 is over here. So it's got to be the straight line graph, which was the first one that we graphed, right? So when x is negative 2 over here, what is y? Negative 1. When x is 1, we're sitting here, which is the middle graph, because negative 1 fits in this inequality. No, it doesn't. Yeah, it does. Positive 1. Positive 1 fits in this inequality. 1 is between 0 and 2. 1 on the graph is also for that equation. So what is its value? 0. And z of 5, if you put a 5 into the bottom inequality, 5 is greater than 2. 5 on the number line is going to place you on the bottom, the third equation given. So that number must go in this third expression and only in this third expression. So what is its answer? Very good. Okay, so there's your graph. We were going to try to do one more, but I'm afraid we're not going to. I don't know if we can do this or not in that amount of time. We might not have enough time because I need to give you a handout. So we're going to close the recording there, but you seem to be answering it quite nicely, so hopefully you have a pretty good understanding.